Thanks again for having me. My name is Alfonso, but almost everybody call me Fons. Today, I'm gonna talk to you about Nerve's ecosystem, the basics, and especially the tools that you have now to start your project. First of all, I wanna share the agenda. And I wanna talk about the basics, some libraries that are really useful when you want to build a project, some tools to debugging and to understand what is happening with your application or your IoT system, and some learning resources. And at the end, some reasons to not use nerves in production. As I told you, I am Fons, I'm Mexican. I've been 5 years digital nomading. That's the reason I ended in some online meetups like Sydney meetup. I've been more than 10 years building software. I first of all started with assembler, doing low-level stuff. Then I knew about desktop applications, and I thought this is easier than assembler. So I prefer to go to desktop applications than web development. And right now I'm more focusing building teams and like coordinate some projects. But at the same time, I really enjoy to build some embedded applications more than systems. And right now I'm leading engineering team for retail based on artificial intelligence. So some disclaimer, these tools and these tips and these basics are based in my experience building a real world product. So probably there are some tools that could be missing in this presentation. And the disclaimer too is that this is not a deep technical talk. So we are just talk about the basics. So I just wanna bring 5 basics when you want to start with nerves. Basically, the first one is Nerves livebook. Just to start, in order to have the same context, Nerves project is like a layout in the top of Buildroot. Buildroot is like a small version of Linux designed for embedded systems. So then some people decided to embed a BIM, the virtual machine, and in the top of Buildroot in order to be able to run Elixir applications. So the first thing that I want to share with you is Nerves livebook. Probably some of you have heard about livebook because it's a good way to start experiment with Elixir, especially for web applications. And we have a version of Nerves livebook that could be run in your devices. So the easiest way to test it is just to go to the GitHub of Nerves livebook, download the latest version, and you need to decide what is your architecture or your device that you have with you. I mean, I have right now a Raspberry 3 B+. I have a Raspberry 0 and probably a Raspberry 4, but you can download for BeagleBone, for Grisp. So you have several options. You just need to decide what to download. And then you just run it and you will have a web interface where you can just evaluate some pieces of code and start to experiment like for web applications, but now inside your embedded system. You have firmware up, that is a tool that allow you to born your firmware in the SD cards. So most of the embedded devices has SD card slot where you can just put your code and then boot your system from there. So firmware up is a really amazing tool to just born easy and fast. And at the end, I will show you some benefits of this. I just needed to talk about Nurse Bootstrap. Basically, you have some embedded commands and functionalities from Linux now in the top of the Vim, so you can just call some tools from Linux from Elixir. So as well as Toolshed, you will have some commands like the basic commands from Linux, like top, like ls, movements in the files, and you will be able to use it like any Unix system. And the ring logger, at some point you will need to understand what is happening in terms of events inside your device. And ring logger is basically a ring buffer where you can just get the events that have been like happening inside your device. So about libraries, we have one interesting thing in the NERVS ecosystem is that now there's a lot of people building libraries. So you have a bunch of support in terms of solve problems that have been in the industry of IoT or embedded systems. And now the community is solving that for the Elixir community. So first of all, we have VintageNet, that it's a huge library that has everything solved for networks. So you have wizards, you have managers of networks. You can easily set up your Wi-Fi, your Ethernet, your virtual network, your private network. So VintageNet has like everything to just mount your library and start to configure your network. Circuits, it's actually here is circuits GPIO, but you have circuits like the main library that has, I think, 4 components. When you have a device like this, you will have some pins. So actually it's an IO. You need to receive data and probably like output something from the pins, but in terms of I mean bits. So basically circuits has solved everything for us. In this case, if you have some knowledge about electronic design, here we have just an LED. So you have an output in your device and you just out like a value 1, a bit with a value 1, in order to turn on your LED. So inside circuits, you have this management for IO, for the pins, but you have probably like UART if you want to communicate with like some other boards, some other devices that are not using the same protocols. I mean, you can connect everything with something more standard in these times, like web APIs, JSON, but we should be able to communicate with some other type of boards. So UART let you communicate through some connectors like DB9, DB27, or some protocol that it's not based on Ethernet or USB. It's all about pins. Another good library that I've been using is Moontrap. So basically inside the Erlang ecosystem, we have ports. We have the chance to run some code, wrote or built in other languages or technologies like C. And especially for embedded systems, we have a bunch of programs and libraries built in C. So through Erlang ports, we are able to run that code inside the Erlang and Elixir ecosystem, but especially for embedded devices, we want to have more control of what that program is doing. So sometimes the ports of the Beam are based in that we will have a good program running in C, but it's not always like that. So we have Moontrap, that it's a library that allows us to get more control about the processes that are running those programs out of the Erlang ecosystem. So basically, this library allows us to really terminate or kill the processes when the program itself has not a graceful sign term or are not managing in a good way the crashes. PID control. This requires that some sort of knowledge about PID controllers. So basically, in some systems, you have a feedback, and you have to take the feedback of your system in order to adjust some params and change the behavior of your system. Something like more known is like probably in a factory, you have a robot with an arm, and the robot needs a sensor that can see if a box is in the right place, and then with that sensor adjust what the arm is doing. And that's the simple concept of PID controller. We already have a good library to build those controllers in order to read sensors, adjust our system, and then action some feature different. CubeDB. In the list that I will show again, I wrote XQLite. So basically, if you can use SQLite in order to have a like little database inside your device. Just to give it an example, I'm using the SQLite database in order to make a queue of events. And when we are offline, we just keep writing the events wait for the network, and when we are online again, we just start to send all the events that all the events that were stored in our local database. But it's a single file database, and that's kind of risky when we are talking about IoT or autonomous devices. So we have another option that it's CubeDB. It's completely developed with Elixir, and especially is designed for embedded systems. And what I think is interesting is that it's not a single file database. Actually, it's like a kind of distributed file database. So it's really helpful when you have the like some problems in the network, or you could like crash your system. It's really helpful to have like these different files, and in the worst scenario, you will just lost a little piece of your data, but not everything. So as I said, we have VintageNet, we have circuits, we have Moontrap, PID control. Even if we can use SQLite, I prefer CubeDB. If you want to have real-time communications with some server, we can use Slipstream to connect the WebSockets. I'm just working with Phoenix channels and a Slipstream, but also you can have like Gun. This library came in from Erlang. And you can have the Poncho apps. Poncho apps is basically a way to embed Phoenix applications inside the firmware, but you have like isolated the code from your Phoenix app, and you just like import your Phoenix app as a dependency inside the firmware, so you can maintain in other place your Phoenix application. So the thing, or the interesting thing here, is that SQLite, Slipstream, and Gun are not really libraries designed for NERDs. Are libraries that you can use wherever you want, but as NERDs is running just in the top of the beam, you are able to bring those libraries and use it in your embedded system. So that's an interesting thing from the NERD project. So now about debugging tools. Inside your NERD system, you have a console you can access through Secure Shell. You can use Phoenix telemetry. So basically, you can implement the telemetry inside the nerves and probably connect it to some Phoenix application in some server and show real time what's going on with your device or with your sensors. You can mount the observer inside your device and remotely. So if you have some system running and you are not being able to understand what is happening, you just can remotely mount your observer and start like tracing and tracking all the processes inside the nerve system. And the magic tool, HDMI. At the end, sometimes as this is running in the top of Unix system or build root, Sometimes you will need just to connect a display and see what is going on if it's not being able to boot your system. There are like an advanced step in NERSC project that it's the custom system. You can like customize your build root version or your small Linux version. So probably you want some package that it's not by default in that Unix or Linux version. So you will need to build a custom system, custom build root system, in order to have that package from the Linux in your nerves. And sometimes that will not be easy. So you will need to just debug in the more simple way. So some learning resources. First of all, you have Elixir School, and you have a focus section inside Elixir School that it's explaining like the basic from nerves, starting a project, burning the firmware, some examples of how to build some applications. At the end, the interesting thing is that if you are already working with Elixir, if you have some concepts of OTP, will be like completely natural. Like most of the work that I do every day in the nerves applications is writing gen servers, because if I have a sensor, I just want to have a gen server that it's reading the sensor and passing the state when somebody needs to, or some other application needs to know about the sensor. If I have an actor, I mean a physical actor, I just wrote a gen server that it's ready to receive a message to start that action. So basically, it's just taking the knowledge of OTP and Elixir and just forget about what embedded system is. The second good website to learn, it's tips.nerves project. It's an amazing effort to list like some tips that will be useful in your day-to-day building embedded applications. Nerves examples. If you look into GitHub, there's a repository, official repository, where you can find some examples of nerves applications, nerves basic applications, but at the end are like some sort of pieces that you will need like for almost all the projects. So you have like the simple application that you just need to turn on and off, like some pin or probably like LED, connections to servers, web applications inside your device, connection to Wi-Fi, like all the basics projects are in the nerves examples repo. So you have Elixir School, you have the GitHub of examples, and you have tipsnervesproject.org. So some bonus links. First of all, in YouTube, under your channel, you have Nerves Quick Start that explains like step by step in less than 5 minutes, I think. how to download the livebook image, burn it into SD card, and just start using it. In the same channel, you have Phoenix Live View on NERS for IoT. That basically it's in an example. This will take more time, probably like 1 hour, to understand how to build the Poncho apps. Even if you have the documentation in the official website, this video will help to understand, like in the real world, how to do it. I think 2 years ago, I saw a talk from Fiona in this community about InfluxDB and sensors. I think that was the first time that I saw about how to connect nerves with servers and send data. It was amazing. At the beginning, I was using InfluxDB to understand what was happening inside my system. Was really useful to make some charts about the behavior of my system. What I can say is that now I am using timescale DB because now I don't want just to make a chart. Now I want to make complex queries to understand how was the behavior in my device in some range of time. So I think timescale it's more prepared to complex queries. But InfluxDB, it's amazing if you want just to chart the behavior of your sensors, your device, your resources inside your device. And the most advanced talk that I've seen in YouTube, it's from Kenny Powell, I think. And it's about the PID control. So here, he built like this piece with a small ball that can adjust the height of the bar in order to move the ball in some point in the bar. So this is a good talk because here he's mixing NERS project, the PID control library, live view to have these real-time controllers, and especially the UI, and also is mixing Phoenix telemetry with the Phoenix dashboard in order to just chart all the behavior without anything out of NERVs and Phoenix. So I highly recommend to watch this talk if you are like advancing in your NERVs project. So just to summarize, NERVs Quick Start from the under your channel, Phoenix Live View in the same channel, InfluxDB and sensors in the channel of this community, Elixir Sydney. And the last one, Live View and Control Systems from Powell Kinney. So why not to use NERVs in production? Actually, there is no reason. It's completely ready for production. Actually, in my current job, we built a solution that has an embedded system in order to control an autonomous point of sales, video record all your activity in front of the point of sales, and organize all the data in order to pass to artificial intelligence and generate an inference about what you are doing and what you are buying. We have a big amount of point of sales in different countries, and we basically are connecting everything to Phoenix applications. So I can guarantee that it's production ready. So I say that it's completely ready because it's really stable. I can tell you that there is not like a gap between versions that you need to worry about. Now it's compiling with 64 bits. We always have the latest kernel upgrades from Linux. So every time Raspberry org or some other organization from a ARM or ARM devices release a new kernel upgrade, it's like completely available in the NERVS project. We have a good amount of libraries, not only designed for NERVS, as I told you. We have all the ecosystem from Erlang and Elixir, and basically we can just mount it in the top of NERVS and the Beam. And one of the motivations for this talk is community. Like I have got a lot of help from all the community. Like all the people, it's always like open to understand your problem. And especially there is a lot of people that has a huge experience building embedded systems, and those persons see a good chance to make easier the way we develop embedded systems and embedded applications. So community have been really important in the building of our product. Some benefits of NERVS. Talking about our product, especially our product, we went from 35 minutes to burn an SD card. Probably at the beginning, we were spending like an hour and a half to just burn our firmware in an SD card. Then we found a way to make it like faster, 35 minutes. Now with NERVS, we just need 3 seconds to burn the SD card through firmware up, FWUP, the tool that I mentioned at the beginning. And now that we are adding some security through AWS IoT Core, we need JDK to manage all the certificates. We just increased like 5 seconds. So we need 8 seconds to burn every SD card when we need to deploy a new device. We went from 1.5 gigabytes to 30 megabytes. It's amazing the difference between a whole operative system against the build root version or the small Linux version. So we were running under 30 megabytes for all our firmware. Now that we have Java inside our firmware, we are in 300 megabytes, but it's not that bad. And one other benefit is that we have total remote control. We have a lot of tools inside Nerve's ecosystem, so we are really able to know what is happening inside the system, not even in the same network. We can do it like remotely from other side of the world. Cross-compiling, as I told you, I have like a different type of devices, versions of the devices. We actually just have one version of the repo with the firmware, and we just cross-compile for the different architectures that we are managing. Supervisors. As I told you, most of the time what I wrote is Gen servers to control little pieces of the hardware, and supervisors managing crashes, and all the tools that OTP has have been like just completely like magic. Phoenix, it's really transparent when you have been like working with web applications and Phoenix just to mount some sort of API inside your device and just to connect to a mobile app in order to have a peer-to-peer connection between your device and your phone. And the second motivation for this talk, it's approachable. I think the Elixir ecosystem has approachable some technology for a lot of people. Approachable, I mean, easier to understand, easier to just forget about concurrency, forget about fault tolerance, and just use the tools that we already have. And I think it's the same in the Nerves project. Has been like approachable for all the developers that has not the background of the hardware or the embedded systems. So one of the, or I think the most important benefit of Nerves in terms of my product, it's that I can just forget about embedded systems and focus in develop our product. So nowadays, my conversations with my team are more about the future, about private 5G networks, mesh networks, distributed AI inference, and a lot of features in the top of our Nerves product, and just not think about the embedded devices. So that's the point of or the value of Nerves. So this is the part where everything can being wrong. As I told you, this is not a really technical talk, but I just wanted to show you some tools that I listed in the talk. So first of all, as I told you, I have a Raspberry Zero over here connected to my laptop. I just downloaded the livebook, Nerves livebook version. If I go to a browser, this device is connected via USB. So if you see it's already running, I just did anything, just burned the SD card, and I already have this notebook to start to experiment something inside my device. So basically you have something like, if you don't know livebook, it's something like Jupyter in Python. some notebooks to experiment code in real time. So you have a bunch of samples of what you can do. I don't know, let me see. I mean, you have like, let me try this. Okay. You have a bunch of examples inside a livebook, and you can just run code inside your device. So everything that you see here, it's running inside the device. I'm gonna go to some place that could be more spectacular. Okay, so now we have charts running in a web browser coming from a Raspberry Zero. So this is like a really visual example, but basically you can run whatever you want in order to test if something could work inside your device. So this is kind of, I mean, when I see talks, it's always like the happy part of, yeah, this is a way you can just download something and try something. But most of the times we don't see how to start and how to build the first step of our projects. So I just decided to show you a little bit how to start. So basically you have all the documentation for installation. But if you're already like, if you know something about the Elixir ecosystem, you have like used some task, you will see that you have mixed nerves that new. So I'm gonna break it, but just to show you that the tools and the ecosystem is like in the same level of something like Phoenix. Like we have all the helpers, all the documentation in order to create projects, and all the examples in the GitHub repo. So I already have a project over there. I just wanted to show you how to start. So basically, you just use a task to create a new project. After that, I didn't want to do this, but just to show you, let me see. Okay, it's not over here. Well, we have some targets. As I told you, we can cross-compile for different devices. So basically, when we want to build something or compile something, we need to define the target. If we don't define the target that we are cross-compiling, our toolshed just will take our host, our computer where we are working, and will compile everything for this device. In this case, my laptop. But you have like some pieces of hardware that you won't have in your laptop, like pins. So basically, you can just define your target. In this case, I'm gonna write the Raspberry Pi Zero. You have a documentation where you can watch the names or the labels for all the devices, supported devices. You just can add it at the beginning of all your commands, or you can like export the variable for your terminal. So now as every
Sorry to interrupt,
reason.
Alfonso. Could you wrap it up in a couple of minutes? We're rapidly running out of time. Thank you.
Okay, yep. So basically, you will have to get all your dependencies. You can build your firmware. And then you will just burn it in your SD card. So just to let you know, I can do mix firmware dot burn, and that will burn my firmware inside my SD card. I just have a new SD card over here. This will tell me that doesn't know the device that I want to burn into, but you just have options like define your device or your path inside your system that you need to burn. So basically, these are like the first steps. If you want to contact, I don't know if we have time for questions, but if you have to contact me, I'm almost everywhere as funds. And if it's interesting, some part of the nerves project where you will have a talk in a deeper way, just share your inquiry, and I will prepare some talk if it's interesting for you. So thank you very much for the time.